Okay, hi everyone, and welcome. My name is Rani Batih. I'm the lead writer in the marketing team at CME. And I'm really excited to be hosting this panel today about the influence of technology on energy management. I want this panel to be the best panel you ever attended on this topic. We're going to try to pack a lot of insights in the next 45 minutes to an hour, but I also need your help to achieve this goal. So get your questions ready for the Q&A session at the end. I'm going to start things off by introducing our panelists. First, we have Ali Aleh. He is the lead hardware and a certified energy manager. Next is Victoria Elzayed. She is a technical project manager with a focus on AI. And finally, Saleh Traboulsi. He is a solution architect with a focus on energy management. All three panelists have extensive expertise in the utilities sector and energy specifically. And they have worked and they currently work on big scale energy projects. I have a lot of questions for you guys. Are you ready?
Yeah.
Okay. Energy management. What is energy? When I think about energy management, first thing that comes to mind is the process of controlling or monitoring energy consumption to lower energy costs. So I'm pretty sure you guys have a much more interesting take on the topic. So in your own words, from your own perspectives, what is energy management and why is it such a huge topic of interest for businesses and organizations around the world?
Basically, if energy management can be very, very simple. So everything we do in our life, like turning off the lights, that's called energy management. So basically on enterprise level, it serves mainly two targets, either lowering the energy bills, lowering the cost of the energy, or meeting sustainability targets. So basically, everything can be done manually, but you can automate it. So everything can be automated. And our role basically is to integrate IoT and AI to automate this process. So basically, it starts from billing collection, understanding the bill, how the bill works, and try to reduce the cost based on that billing structure. And also, it also includes some controls to control the loads that are connected and to monitor the energy. So basically, this is how we automate it, but it's a very simple act that we do every day.
Simple to you, probably.
I just want to say, of course, I'm aligning with Ali on the perception that he gave. He described it perfectly. But I would like to define it by the way I like energy management. So I like being in this field because energy management is a way to achieve sustainability targets. So we monitor and control energy, but in the target of meeting our needs, and at the same time, we reduce energy waste, we reduce gas emission, carbon emission, and we preserve resources. So that's what I like about it. Yeah. And of course, we reduce cost and so
on. Same to what Ali and Victoria said. How I can see energy management is, I think it starts with the process of monitoring, controlling, and optimizing the energy use. And I think that will lead into energy efficiency, reducing the cost, and also lowering the carbon footprint. I just want to highlight one important aspect of energy management, which is monitoring. That means having a sufficient and valid way of collecting metrics, since these metrics will be used later to provide insights and to take actions. So if these metrics are not accurate or if they are not sufficient, then that would affect the efficiency of the process of energy management.
We'll talk about this later on in details. So let's dive into our first big section today, which is IoT and energy management. So how do you define IoT in the context of energy management?
Well, just to keep it simple, maybe not everyone knows what is IoT. IoT refers to a network of physical devices that usually collect, share, and act data. And usually we use IoT to promote automation and to promote the operations in an efficient way. IoT devices could be smart lights or switches. Speaking of energy management, could be HVAC units or smart meters. So using IoT in energy management, I think IoT plays a crucial role in energy management. Starting from providing the real-time metrics that can collect, for example, power metrics of a specific equipment or site, sending it to the server, for example, for curation or for ingestion or a processing. And I think that would give the opportunity for the operators to understand the energy consumption of that equipment or of that site and to make decisions upon these metrics. Again, these actions will be pushing toward reducing the cost of energy and using the energy in more efficient way.
Basically, before having the IoT concept, we had a lot of distributed private networks for controlling devices. The devices that had communication way on a private network, on a site, or in a building, in a facility. So basically, that's a limitation because you cannot control two sites at the same time. You cannot relate the data. You cannot get enough information from that data. Connecting things to the internet, it opens things up globally. So if you have facilities in two different countries, you can learn from one and apply the rules on another one. And that's the major role IoT plays against automation, normal automation that we're used to.
So let's give an example of on-site. I mean, what role do IoT devices play on-site in energy management? I mean, how does real-time monitoring, smart meters, and sensors, how do they all work together?
Yeah, so basically, a part of IoT, we have multiple levels of devices. We start with the smallest sensors and controllers, and then we go up to edge computing. So mostly we have a facility controller, we have a part that controls this network internally, and that's mainly to save some data and make decisions faster. And then this device can go to the internet. So the data collected can be viewed and analyzed on some sort of servers. So basically, on the lowest level, we do have devices that can sense any physical information and convert it to electricity, and then this electrical signals can be converted to communication to go to the internet. So they are digitized and they are sent. On the other hand, we also have controls. So if we want to turn on the light, we need something to control the light. We need something to open it, to close the circuit or open it. So this is at the core. We have these devices. These devices usually have firmware running on them. So they have software running on them. They are some kind of smart, but they cannot be very smart because they have limited resources. Usually, when we go a little bit up, we have the edge computer. Usually, this has much resources, and the open resources are on the internet. So mainly, this is the core, and this is the structure of how things work.
So when we talk energy, we always talk about smart meters and sensors.
Correct. Yeah. So basically, for the energy, it's similar. It's a metric or a physical data that we are measuring. We measure the voltage, we measure the current, we measure the power, we measure the energy consumed, and also at different levels. So it depends. You can measure at the outlet level, you can measure at the breaker level, you can measure at the facility level, which is the utility meter. And this information all correlate together to create, to basically to be the information for you to decide what to do. And once you decide what to do, you need something like to act. You either need to turn on the light, turn off the light, increase the temperature on the HVAC, and decrease the temperature on the HVAC, and so on. So you need something, also an IoT device that can accept signals and act accordingly.
Okay, and they do provide data for consumption patterns, right?
Correct.
And
So collecting these data, whether it's instantaneous data or cumulative data, data like energy is cumulative data that accumulates over time, and data like power, which is also important for us, it can lead to other decisions. It's instantaneous, and it can lead to instantaneous decisions, and these are collected as well. So depending on the data, we take these decisions, and then they are saved for analysis for later on.
okay, perfect. So it's what challenges might arise in IoT implementation? I mean, there's a lot of factors to take into account when implementing IoT, right?
Yeah, in fact, the providers that provide facilities to manage and control IoT devices, and the technology behind them is kind of new. So that comes with a lot of challenges on like different levels. Speaking of that challenges, for example, the scalability. Usually, we manage thousands or like tens of thousands of IoT devices, and that a little bit challenging to be able to monitor and control this huge amount of devices at the same time. And usually you don't have like physical access to that devices, which makes it harder and harder. Another challenge, what I can think of, is security. Since we don't usually have physical access to these devices, we don't always control the network that these IoT devices are operating on. And you know, it's crucial for us to maintain the user data and secure that data. So we always do our best to transmit that data in an encrypted way or in a secure way to the facility controller or to the cloud. Another challenge I would think of is compatibility. Since we usually use IoT devices from different vendors, not from one specific vendor. So we usually have compatibility issues using existing protocol versions and the accepted protocol versions by the service providers, for example, cloud services. So that's also a challenge for us. But I would like to listen to Ali's opinion about how we can protect, in terms of security, the device from being accessed from unauthorized people. Since we don't usually have access to that device and installed in like thousands of meters, thousands of sites. So I would like to understand from his point of view, from the hardware point of view, how can we secure better these devices?
Yeah, so basically talking about security in IoT, we basically have two threats. The first one is someone getting into the device and controlling what's connected to it. That's like if you have a meter connected to the facility, to the building, someone can get into the meter and turn off the electricity from the whole building. It could be like if you are in the hot summer, someone switches the AC from cold to hot, and it will be very, very hot. So these threats are one side threat. The other threat, which is usually seen as bigger from IT personnel, is someone using this device to access the network that is connected on. So someone using this IoT device, because it can be opened, it can be programmed, and then someone can program a malicious software on this device to access the network itself. So basically on the firmware level and on the hardware level, we add some chips for authorization, or we add a partition in the memory of the device that is secured, and that usually have a certificate that the firmware is signed using it when compiling the firmware. We sign it using this certificate. So once it's flashed to the device, once it's loaded on the device, no other firmware, if it doesn't have this certification, if it doesn't have this signature, works on it. So this is one way to control it. On the other side, when you get into the device, it uses the same methods. Everything you other than IoT uses. It's like encryption, using multi-layer encryption. You can use multi-factor authentication and so on.
Yeah. Thanks.
You guys have solutions for everything. Great. Moving on, Victoria, how does IoT help in preventative maintenance? I mean, how does it predict potential failures and such?
Yeah, well, IoT provides data, and this allows data-driven decision. The cool thing is that we are getting real-time data. And what happens actually is that you have data collected, and you have on the other side, for example, a predictive analytical model that is analyzing this data and detecting deviations or abnormal behavior. So to give an example, let's say we have a restaurant, we have in it refrigerator, ovens, you have in it other equipment, and you have IoT devices collecting metrics from these devices, from these installations. One of these is temperature. On the other side, you have a trained model that's already trained on historical data and already knows the normal behavior. So at some point, you are getting real-time data, and this model is checking and noticing that there is an increase in temperature in the refrigerator. And this means that this might be a failure or start of failure in the compressor of the refrigerator. What happens is that automatically an alert is generated, operations take action, they go to the restaurant, they fix the refrigerator in case there are issues, or see what is the problem. And the cool thing about this is that you don't need to have the failure to take action. So you kind of prevented a failure in the system and took action ahead. And this is where it helps.
Yeah, I have a question for Victoria. Usually we have scheduled visits to the sites to check the HVAC filters or to check the health of the equipments. But in your opinion, how could AI help in making these visits more efficient? That means if I have 6 scheduled visits to that site that is costing us thousands of dollars, how we can use AI to minimize and optimize these visits?
Yeah, so you already have collected data over years of your maintenance schedules, and when it was needed to take actions, when we should have went earlier. So you already have tens of years of data. And based on this, you train a model, and you see when, for this site or this brand, this type, how frequent we should schedule maintenance. And this is where the strength of AI is, that it can do or detect, or it's based on patterns, and it can help on this. So it's you can link it to a specific brand to say that we need, for restaurants, for example, to do more site visits or scheduling of maintenance than others. And this also where plays a role the age of equipment, because equipment degrades with age. So you can know and get alerts that this equipment you will need to schedule a visit for it, because based on the history, at this phase it's being degrading.
Yep,
So,
I
yeah.
got your point. Ali, since you have a background in electricity, how real-time metrics or the data collected by the real-time metrics would be beneficial for us to detect potential failure. For example, a drop in voltage or registering a higher consumption.
Of course, they can all be used, especially if you're talking about cooling systems or heating systems. We can always correlate the input with the output, so that would be the best way to do it. So in case we can't correlate the input with the output, that would be the best way to detect any failure or avoid any failure to prevent it. So what I'm saying is, if you have a cooler, if you have a fridge, and you have a sensor inside, and you know how much it's drawing electricity it's drawing, so you can correlate this data, and you know how efficient it is. And knowing how efficient it is means that everything is working well if it's efficient. And if its efficiency is dropping, then you know that there's something wrong. Usually you can have a gas leak, you can have a clogged filter or something else.
Okay.
So that would be the best way. But if not, you can depend on a single parameter, then you need AI to do it. You need to detect the patterns, basically.
Thanks.
All right. Now that the data accumulated through IoT also serves as the fuel for AI systems. And that plays a major role in analyzing and optimizing energy systems, right? So how does AI support distributed generation? I mean, how does it manage decentralized energy sources?
Okay, so one way where AI is used by utility providers, actually. So they use AI to coordinate when there is a need to have the power stored in batteries, when there is low demand, and when it should be dispatched when there is high demand. The other use case is forecasting. So utilities do forecasting. Let's say 3 days ahead, we know that there will be a peak in consumption. So they trigger the demand response where they provide initiatives for some organizations to reduce their energy consumption. And they do this by forecasting and by using AI models, actually.
I'm curious, what kind of considerations are involved in selecting the right technology for specific sites? I mean, what does the process involve?
Well, one of our solutions actually is around your question. So we have a model that gives you for a specific site what is the effect of its installations or technologies on savings in it. So you can know ahead that if I do an HVAC replacement, I will get 20% energy savings. If I change my LEDs, I will get 2% savings. And this is done for TSTAT for different technologies. And this is where it helps. So you can check that the savings ahead before going and doing installations.
Just one comment to what Victoria mentioned. How I see it like a full cycle. So, for example, it starts from a demand or like a request from the utility provider to lower the demand or the consumption of electricity. So the whole system or the energy management system would capture this request and react smartly to it, using IoT, using AI, based on the historical data, based on external factors, for example, the weather or the peak time or other expected factors. And I think that full cycle utilizes IoT, AI, set of microservices and AI models.
Well, I'll try to put it in some simplest terms. So basically, what technology is used to reduce energy? To reduce energy, It depends fully on the site where we are putting them, where we are installing them. So if they have an inefficient cooling system, we need to change the efficiency of their system. So we need to replace their system. If they don't have metering that we can read, we need to install it. So this is by simple terms. We need to check the sites first. So it starts with an audit of the site, and then checking what technologies do we have, and then we decide accordingly. And also the site audit can include what type of walls they have, what type of ceiling they have. So there are a lot of energy measures that can be installed or modified to reach the targets. And AI can highly help on this because there are million parameters that can affect the energy consumption. It could be the light is too strong and it's consuming more than enough. Maybe the cooling temperatures they are setting to, they are very, very low for cooling. You can increase it and that's it. So it could be very simple, but there are millions of parameters that can affect the decision, and here's when the AI is really important, because there are a lot of things to think about. You need something to recognize patterns and correlate what's in the audit with what technologies we have and what is the outcome we get.
Right. Definitely, Ali, what you are saying is right. I mean, it's right to the point. Because our model, the site type is a feature in it, so it's an important factor. The location, the sites, the weather in the region, everything plays a role in the predictions that is made on the savings.
The insulation, what you have inside, all these may make difference. So the audit or the data you feed to the AI is more important than the AI itself sometimes.
Exactly.
It's the base. Data is the base, actually, and the computing capacity. So both of these are the base of AI. Yeah.
Agreed.
In terms of billing or meter data, how does anomaly detection is used in energy management? I mean, talk about the role of AI in identifying discrepancies in billing.
Yes, so in AI, our model is already trained on normal behavior or standard pattern for a site. So anomalies have different phases. One, we have solution that detects anomalies at site level. So if a site has a history, and on this month, specific month, it has certain behavior, and we got the bills and we noticed a different behavior, it means this needs investigation. The second level of anomalies checking is at the site type level. So if we have a brand that have this behavior and at some point we notice a deviation on the pattern, this is flagged as anomaly for inspection. The third level, it kind of includes another modeling. So it detects the current billing that we are getting, and it compares it against the predictive consumption. So we predict that, and let's say in December, the usage in this site should have been 8,000 kilowatt. While we got the bill, it's 10,000 kilowatt. So this is something to investigate also. And the fourth level, let's say, of anomalous detection, it's different. It's not based on billing. It's based on IoT data, on real-time data, on the metered data. So this one, the difference actually between these anomalies detection is that this one you can detect it ahead. For billing, you get the bill from the utilities and you pay for it and then you inspect. So one of the solution is for projection. So let's say today we are 22 January. We have a model that predicts end of month what the site will be its consumption. So let's say if we are early January and we notice that in the first couple of days our projection is way above what we expect, this means that we can detect ahead and check why there is overconsumption in this site.
I would like to add something
Go
here,
ahead, please.
Rani. So basically, this is from the client or the downstream view. So if we are behind the utility meter, this data can be used also, metering data from meters installed by the utility itself, can be highly used and can be highly valuable to classify the losses at the utility level. So with the electricity delivery starting from generation to delivery to the final client, there are a lot of losses, and some of them are technical losses, which cannot be avoided. Other losses can really be avoided, and part of them is tampering. It's like someone just hanging a wire on the network, and AI can really help on this because these patterns can be detected if the correct data is fed to the AI models. So this would be a very good application as well. We had a project that we started on. We didn't complete, unfortunately, but we do have the basis of this. And this is really needed by the utilities.
I have a question for you, Ali. Since we previously worked on this specific topic, how does AI optimize HVAC performance?
Well, basically, as we talked, HVAC is one of the systems that can highly vary with the surrounding. So we cannot just depend on one setting for all sites that we do. The previous or the old mentality and the control of HVAC was to keep the settings, the setting of the set points of the target temperature, to keep it a single temperature, constant temperature across all sites, everywhere. But this actually doesn't work because every site has its own variations. So basically, we need to understand how the site is acting on different set points, on higher or lower set points, and we use this to change our thermostats. By the way, we do thermostats, so we can change our thermostats by signals from the AI system to raise or lower the temperature, the set points, the temperature of the site, based on the energy targets and the comfortability as well at the same time. And another way is we get insights on how efficient the system is. So knowing the outside temperature, knowing the insulation installed in the system, and how long we need to reach the cooling targets. That gives us a lot of insights on how efficient our system is. So maybe we can signal something to change the cooling system or to clean the cooling system, which goes back to the preventative maintenance that we're talking about.
All right, great. Do you guys want to mention anything about AI before we move on to the next section? No, nothing.
I think we are ready for the next session.
All right. So our next and final big section is actually data analytics. So as I understand, one of the many roles that data plays in energy management is to actually validate the accuracy of AI and IoT. Can you talk more about that, the validation aspect?
Well, I think that's one of the important aspects. Since the cycle starts from collecting the metrics and validating its values, if it is right or we have bad configurations or bad wiring that is resulting in this bad metrics. I would say leveraging the historical metrics of specific equipment while installing or configuring similar equipments is very important, since it gives us the ability to do comparison, to understand the efficiency of the existing configurations in these conditions. Another important thing is that when we try to install a specific equipment on a new site or an existing site, it makes sense to also do sort of benchmarking to understand the efficiency of that equipment and how the configurations are used to optimize the operational side of that equipment. So understanding the consumption pattern, we are getting from the historical metrics of that equipment or similar equipment will be very beneficial. Also, it would give us insights on understanding the equipment performance and to be able to identify inefficiencies. Also by comparison. So using AI modules to compare similar equipments to try to simulate specific conditions and try to figure out what is the optimal configurations that can be used for this kind of equipment is very beneficial.
Can you talk more about exploratory data analysis, EDA, and how is it? What its main role when we're talking about sites?
Well, here for AI mainly, how do we start on a solution? So Saleh is collecting billions of data points daily and storing them, and we come as AI engineers or AI team and get this data and we want to build our models. The first thing that we do is that we check the feasibility in terms of data availability for our model. The second step is we run EDA, exploratory data analysis. And the purpose of this analysis is to identify patterns, to identify what features are playing major role in this data. And mainly to identify also if there are outliers. And this data analysis triggers later on the cleaning of data, what should be filtered, what outliers should be excluded, how to build our model, what are the features that should be in this model. So EDA plays a major role in modeling a solution.
Okay, excellent. I have a controversial question. Why is education in energy management and data analytics important for engineers who work on energy projects?
Well, domain knowledge. Domain knowledge, you can have the best skills, you can be the best engineer, but if you don't have the domain knowledge, there is a risk of failure. I have a short story not related to energy, if I can say it, related to domain knowledge.
Go ahead.
Around 20 years ago, we worked on a solution for radiologists. We built a virtual work list. And for this one, it was one of the best projects I worked on. Very good architecture, very good best practices applied. We used aspect-oriented programming. We used Flex. It was booming ActionScript for the people who've been for a while in this industry. They know about Flash Player and ActionScript and so on. And we had a great UX design for it and so on. We were very happy from all angles, and we gave it to radiologists. And the first comment we got is that we work in dark rooms all day. This is too bright for us. We cannot use it. It's too flashy. It was animations with colors and so on. We met the business requirement. I mean, orders are processed, historical information, everything was great. But it didn't serve the purpose because we didn't have the domain knowledge. And same applies on any industry we work in. We need to have domain knowledge to have our mission complete successfully.
I would like to add something. That having a baseline understanding of energy management and power metrics is very important while working with energy efficiency solutions. Since if you don't have that knowledge, how would you be able to validate that the collected metrics are correct or not? Also, you will miss identifying opportunities to optimize the energy consumption. If you see the data, but you can't understand what that metric mean, it will be very hard for you to be able to understand and to capture the opportunities and apply optimization and to identify the inefficiencies. What I finding challenging in that domain is that besides the technical knowledge and besides the business knowledge for the clients that we work for, we should have a strong knowledge in electricity, in energy efficiency, in the metrics that are coming out from the smart power meters, the water power meters, and the HVAC. And as Ali was mentioning, HVAC are not very straightforward like nowadays, since we have tons of configurations and tons of metrics that we need to take into consideration while setting up an environment. So it's not just setting the set point and that's it. We have a huge amount of configurations that we need to set based on like different analysis and knowledge in that field.
Some additions to what Victoria and Saleh mentioned. I totally agree with you, but also knowing some terms that are used in the industry is really important. You cannot. Sometimes there are some terms used in the industry. You cannot even think about them if you don't have previous understanding. So let's say demand response. It means nothing to anyone. You know, this is something, and there are a lot of terms that we need to know prior to start working on this. And also, if we don't understand how electricity works and we don't understand how energy works, if you don't understand this, sometimes you do actions that higher the cost instead of lowering it. It can higher the energy consumption instead of lowering them. So you need to understand how energy works in the bottom line. So we need to know that cool is a form of energy, heat is a form of energy, and it needs an energy to be generated. These are the basic requirements that we need.
And that's the way I always see the uniqueness of CME. It's in the domain expertise, right? In every project that we take on, we are top domain experts.
Correct, especially in the energy. We have a big experience and a long experience in energy. So we do have energy certified energy managers from the Association of Energy Engineers. We do have the hardware to start the lowest block and the chain. We do hardware design. We do firmware design. We do the software on top of it. We do the architecture, the complete architecture, and we end to end in the AI, which is the highest level we work in. So we are especially unique because we provide the end-to-end service, including the business knowledge and energy. We know the industry, we know how energy works, and how energy can be saved, and how energy can have a lower cost. So I think that's in my opinion. I don't know if you have additional comments.
No, I'm aligned with you. So we have the end-to-end knowledge on all angles in the solution. Yeah.
All right, so I guess we covered everything. We talked about IoT, AI, and data analytics in energy management. I know there are a lot of experts in the crowd who will probably do a better job than I did at asking questions, so please feel free.
Thank you. To know more from Ali, the importance of or our experience in really engineering IoT devices and what are the benefits that this represents for the client, to have their own IoT devices, and which parts of the actually cycle do we handle? As you mentioned, it's end-to-end. Can you just clarify this?
Yep. So we worked in IoT as CME. We worked in the IoT for multiple clients. So we can start from defining the requirements, selecting the technology that we use, whether it's the communication technology, the materials that can be used, because the materials are very important depending on the environmental conditions. For example, if we are putting something in the factory, it's different than putting it in the office, and it's different than putting it outside. So there are a lot of considerations that we need to take in engineering the IoT device itself. This is one point. Another thing, we have extensive knowledge in working with IoT supporting services systems like Microsoft Azure and Amazon AWS and so on the software level. And of course, we've been talking about AI. So we can engineer the whole solution, including the architecture, from the smallest device to the biggest problem we have.
If there are no questions from the crowd, we have questions from the chat. The first question is, do you think that the wave of generative and agentic AI can enhance the energy management process specifically on edge device side?
We have currently actually one of our solutions for HVAC optimization. It's to be running on edge devices. So this is the HVAC optimization that Ali was talking about. So yeah, and it's not generative if you want to differentiate. So this is not a generative AI solution. It's an optimization model. For generative AI or LLMs and so on, we use them mainly for domain knowledge. So to increase operations, efficiencies, and so on.
Yeah, I just want to add something. We need to keep in mind that the edge devices have limited resources in terms of memory, hard disk, and the processes. And mainly there are other processes running on the same device. So we don't own all the resources to perform specific computation. That's it.
It feels like you're gonna have like a building fully monitored with all equipments and like data coming in and full energy management depending on the site. So it could go from the elevators to the rooms to the HVAC to everything, like everything happening. So first, how do you see this evolving in, say, like 5 years? This is one. And are you seeing, from a sustainability point of view, how... I know that like solar panels, you already get like the energy, but it feels like now you only use the energy from renewables without really connecting to IoTs, or am I mistaken? Are you seeing like a reconciliation between using also renewable energies into this whole system, like for a sustainability point of view? And another question, can you give like a real life success story that happened in one of the projects where you used all this?
Yes. I will answer the first question first. Yeah. So for the limit, there is no limit. There is huge possibilities, and given the technology progress and so on, and the renewable energy progress also. So there is no limit or huge possibilities in the future for this domain. And there is a focus global-wide on this domain for energy management. So there is a big support on it. And so this is for the first question about the limit or where we can see it going. For renewable energy, it plays a major role in what we are doing. Because if you want to be efficient, if you want to reduce waste, so what do you do with the energy? You use renewable energy, you use batteries, you use this kind of equipment so this is the base actually for energy efficiency. I'm not sure if I answered your first question or...
So say, for instance, you were talking about the systems, the HVAC systems, and you're saying you need to replace. So you also embed, like using the energy from outside to cool, for instance. You let it hold. I don't know if it's...
At this point, on the ground, no. But is there a plan for it? Yes.
All right. Yeah. And you're saying no limit. What do you mean by no limit? Like, how do you see it?
Given the evolutions that we are seeing today, so giving the evolution in the industry on all levels, not only in energy management.
Okay.
There is a huge possibilities. So, yeah.
I can draw a picture of what I see in 5 years actually. Knowing about that there are many consortiums of companies trying to standardize a lot of energy communication between different systems. I think everything will be connected and everything will be working without any human intervention. So basically, let's take the utility now have in many states and the United States, and there are a lot of consortiums and suggestions for protocols that can utilize the data sent by the utilities to consumers, and these are all automated now. So they can send, let's say I'm a consumer, I have an electric vehicle and I have a charger for the electric vehicle, and the utility now can talk directly to my charger and tell the charger when to charge and when not to charge. So right now it's still very small scale, but it's going to scale really fast. And AI will be taking all the decisions from the utility side to send these signals, and from the client side to receive these signals and analyze them and act accordingly. For the solar, it's nothing separated. So it's exactly the same as an electric vehicle. It's a source of energy that is installed. It may cost a lot, and it may not reach the targets of the return of investment. But if it does, it's handled like any other resource you have. It's like a battery you have. You decide when you sell and when you don't sell, you know. And sometimes you have even lower costs than solar. For example, for the HVAC, for cooling and heating, you can use something called geothermal, which is digging something in the underground and get it. For cooling, it's more efficient than using solar power. So solar is not the only renewable. There are a lot of different renewables. And for success story, I have a success story. Actually, it was done manually like 10 years ago, but it was a real success. So on energy management, I mean. So we got a store that has X amount for billing for every month billing, and over the course of a month, we analyzed all the bills in the past probably 3 years, and we found that the bill itself, it has something called ratcheted peak demand, which is if you reach the peak for 1 month, you will be charged for this peak for the next 12 months. So, and that was like 40% of the bill itself. So we installed our devices in the store to get information about how things are consuming and what can we control. Once we understood that, we limited the peak at a certain limit that is much lower than the old peak. So we're able to save this 40%. Additionally, we installed something called demand management, which is we don't allow two fridges to work at the same time if they are doing the same job, if they're doing the same thing, and have good temperature. So if the temperature is good, turn off the fridge. By this, we avoided more 20%. So we saved 60% on the bill, and at the same time, we increased the energy consumption. So we would not reduce the energy consumption, but we were using the energy during lower peak times where the energy cost is low. So we increased the energy consumption, but that's not important for us. The most important was to save the bill, and we were able to save 60% of the bill.
So I have a question I have been thinking of lately, and I might have some false assumptions, so you can correct me if I'm wrong. It's related to energy. So if you have an energy generator that generates, let's say, 1 megawatt of energy, and it's connected to some houses, but these houses are not using the full energy produced by the generator, so we will be having some loss of energy. How can we prevent this, or how can we convert or use the other energy or detect if this energy might not be used. So we generate the exact amount that will be used in energy. That's it. Thank you.
Actually, I have an answer for this. It depends. It depends on the technology that you're using to generate. So some generators they have adaptive controls. If you have a small generator, they have adaptive control. They consume energy. When you reduce the load, it reduces the consumption right away. It's not the best efficiency, but it's not working on the full efficiency of the full capacity. However, if you have a nuclear site, you cannot do this for this. You cannot do this for it. So what utilities usually do, they store this energy. They store it either in batteries, so they have their own batteries. Nowadays, they are using people batteries. Like if you have a solar system that have batteries, you can connect it to the system, and you charge at very low cost, and then you can sell at higher cost. Okay, and the traditional way of doing it is storing the energy in reservoirs. So you have a water reservoir that is elevated. When you have excess energy, you turn on the pump. You pump the water from bottom to the top. When you need this energy, you pump the water the other way.
Ali, what about selling the excess of energy directly?
Well, usually utilities in developed countries, when they have excess energy, they offer it for very low price. And when they need energy, they increase the pricing. So this is how usually they let consumers do it. And if you have storage, you can make real money from this. Just buying and selling. You buy low and you sell high.
By the way, thank you. It was a great introduction as a software engineer. Ali, you're already speaking terms we don't know, so we're already behind. I just have a question for Saleh. Saleh, you were saying that the role of AI is to somehow optimize visits to sites, so we reduce costs, right? So what do you think of AI in general with energy consumption? Will it create more business opportunities for engineers in the future, or it will decrease them as we will need less engineers with the introduction of AI and automation and IoT devices? I don't see that engineers will have more business opportunities in the futures. I'll see those systems when the data is trained and there are a lot of already existing systems that's gonna replace somehow those engineers, and you just need some business knowledge just to filter out data, filter out layers, and I think this will give us less opportunities as engineers in the domain in the future. So I would like to see your insight on this topic.
Well, that's an interesting question. The idea about reducing the site visit is just an example on how we can leverage AI to reduce the cost. And the cost could be in energy or for the technicians or for the wasted energy. So on one hand, we try to reduce the cost by lowering the consumption or lowering the unnecessary actions that might cost us money. On the other hand, to perform all the AI work or the IoT work, you still need people to do that. That means you need more computational power, more resources, more people managing all the models or the functions or the edge controllers that you have in place. I'm gonna give you an example. How can I see it? If you go, for example, 10 years back and understanding the monolithic applications, what I think is that we were focusing on the application itself. It has set of drawbacks, and it uses, for example, limited number of engineers working on that applications. When we moved to microservices, Many said that since now we are isolating the logic, we have very specific services, so we don't need all of that people working on the whole system. We just hire engineers that are working on the hot services that we usually do. But that turned out not to be correct, since moving to that architecture required from us to hire, for example, DevOps, to hire coordinator to coordinate all the releases, required from us more resources to operate these services. And I see it in a similar way, from going from a dump systems or IoT devices that are not leveraging AI. I see it in the same way. So when you introduce something, you need to maintain it, you need to keep it up to date, you need to keep the competitive advantage of your solution versus other services that the vendors providing. So I would say AI and smart IoT devices would make our work more efficient. They would reduce the cost in some way, but they will not replace the engineers that work behind these technologies. Another example, maybe 3 or 4 years ago, we thought that AI would replace people, especially generative AI and LLM models. But now we are making use of these technologies to be more efficient. But we are still working as software engineers, so we are not replaced. And I don't think this will happen in any time in the near future. Unless Elon Musk have a different opinion.
Yeah, I want to add something. Definitely with Saleh, with what he's saying, I have the same vision. No one in the far future can answer the question of the role of AI or what will be the case in the far future. But at this point, or the near future, AI role is not replacing people. It's to optimize their work. So things that used to take with you days should be taking with you 10 minutes, planning for something, optimizing something. It could help on this. And currently AI models and so on are good at one mission, at one task, not like human. So they are great in doing one task or in one area. They don't have the global handling like human being. So for me, I see it as something that will help us in all aspects of our life, not only in our work, to optimize things.
How should we handle IoT data in the event of an interruption caused by power or network issues in IoT devices? Are there specific strategies or best practices you recommend to ensure data integrity and continuity?
Well, speaking of the data continuity, most of the IoT devices are designed in a way to work offline. So if there is no internet connection on a specific facility, they can still communicate using the local network. They use different strategies to store the data for a configured amount of time, let's say. And when the internet is back, they publish that data into the cloud system. So ideally, no data will be lost. But what we will be losing is that our direct control on that device. So we will not have the ability to directly communicate with that device to adjust its behavior, since there is no internet connection. In terms of data integrity, there are different ways or like different levels of achieving that. Ali, we're talking about what we can do at the hardware level to make sure that the data is clean and it's not stolen or it's not changed by anyone on that network or from outside. At the software level or at the firmware level, there are many techniques that can be used, starting from generating certifications with very limited policies to ensure that that device is capable of doing 1, 2, 3, nothing more. So, as I mentioned, there is a set of measurements that we can take into consideration at the software level and at the hardware level to make sure that the data integrity.
Thank you, guys. My question is, what's the contribution of IoT on energy saving comparing to other, let's say, incorporating renewable energy and managing the load maybe? Is it that high to develop it, or just for fun, or just to have a competitive edge over something in maybe preventive maintenance, or but is it the best way to impact the energy saving?
Can you
Do you
elaborate
have a
more?
number or a statistic?
I didn't get the first part of the question.
So let's say if I want to save energy, I can opt for different solutions. Let's say I can incorporate renewable energy if it's possible, or I can like substitute my equipment with efficient new ones in order to reduce energy without knowing any pattern or having a lot of data that I don't need. I just can replace my fridge or my HVAC. What's the impact, or if you have a number, what's the contribution of IoT to increase or to impact this energy saving report at the end of the year?
Well, I will take the last part of the question. Mainly, IoT will give you the ability to understand your device consumption. Since without understanding the device consumption, it will be very hard to make any action to, for example, optimize its consumption or replace it or installing a controller on that device. So IoT, besides the data analytics, will allow you to understand that consumption, to check the efficiency of that device in terms of performance and cost. For sure, yes, there are other available solutions that we can take into consideration using renewable sources and so on. But what I think it is important is that IoT gives you the ability to examine the return on investment of any actions that you might take. Since without these metrics, it's very hard to take actions, and you might take the wrong action, right?
And also, it's used to validate whether the action you made saved you energy or not. So this is very important to validate, so to know if it's saving or not. You need some sort of data metering especially when you have contracts with clients. You cannot tell someone, I saved you something, but you don't have proof. So this serves as proof if we don't think about other items.
Yeah, I would like to emphasize this point because data. Yeah, no, I just want to emphasize it because it allows you to take data-driven decision. In any optimization task, even in software engineering, you need to start by baseline data to know the effect of the optimizations that you made. So this is what Ali was also saying, that how you will measure that you did optimization. And you will base your decision on data and not on assumption. So I assume that if I install this, I will get energy savings. But who told you after installation that you have it? So,
just to let you know something, that at some point when you decide to introduce IoT, you might increase the cost. We have seen cases. We tried to do metering on specific sites, but to be able to do meterings, we need to install our private network with internet connections, and start reporting metrics every 5 seconds. But that would come with a data consumption cost. So you might end up paying for the data consumption more than what you are saving using IoT.
For organizations in developed countries, they need to submit their carbon footprint, I think. So they are report about emissions scope 1 to 3. And also having these data collected will help in this reporting. So there are many uses of the data on all levels. Thank you, Saleh.
All right. So thank you all for attending and thank you for the great questions. And finally, help me thank our awesome guests, Ali, Victoria, Saleh. Thank you so much for the great insights and your hands-on expertise. See you next time.